Well, thank you everyone for coming. Thank you for inviting me. My privilege to be here with you this evening. It's my joy to talk about astronomy, and a subject which I think is somewhat underrepresented in the creation movement, because a lot of people seem leery of it for some reason. In fact, we should probably talk about that up front. The rumor that you've heard is not true. It is not true that excessive stargazing will cause you to lose all your hair. So I thought we should clear that up front. Is there a way to turn the lights off just the front here? Because a lot of my slides are on the dark side. Okay. Oh, we kind of need, okay, for the video, fair enough. Okay, so my topic tonight, as you can see, distant starlight. Does it disprove biblical creation? You probably know in advance the answer I'm going to argue for to this question. But it's a very popular question, and if you spend time in the creation movement, you'll find it's one of the most frequently asked questions, not only among believers, but also among unbelievers. How do we see light from these objects that are so far away if we live in a universe that was created not that long ago? And it seems like a fairly straightforward issue. Because in order for us to see something that's far away, or for that matter, something that's close up, it has to either emit light or have light reflect off of it. It has to come in our direction, and we need to receive it. Now, the farther away the object is, the longer it would seem to require for the light to get here from there. So how do you calculate how long it would take for light to get from somewhere to here? Well, this is a fairly simple calculation, actually, and it's the kind of thing we do in our everyday lives. For example, if you need to drive 120 miles and you're going to go 60 miles an hour, how long will it take you to get there?
2 hours.
2 hours, exactly, because you just divide the distance by the speed, and that produces the time that you will need. Now, we can apply the same formula to the cosmos and to these objects that are out there producing light. Take their distance, divide that by the speed, which in this case is the speed of light, and that should tell us how long it requires for light to get here from there. So for example, the Andromeda Galaxy is 2.5 million light years away. And in case you don't know what a light year is, despite the kind of confusing name, it's not a measure of time, it's a measure of distance. A light year is the time required for light to travel for a year. I'm trying to think about multiple things here. So, if the Andromeda Galaxy is 2.5 million light years away, it would seem that it requires 2.5 million years for light to get here from there. And this is actually, as cosmic objects go, our next door neighbor in space. We see things that apparently are billions of light years away. Thus, it would seem it requires billions of years for the light to get here. The furthest object we've seen so far, the article you mentioned was a star. There's a galaxy now that's a little bit further away than that even. 13.5 billion light years, this specific galaxy. So a straightforward look at this problem would seem to indicate this object requires 13.5 billion years to produce light that we can see. Well, it produced the light, we would need that amount of time to see it more specifically. And the skeptics, the other side of the creation-evolution debate, think that this is a great argument for their side. In fact, it seems to be a knockout blow from the perspective of many of them. This is the Rational Wiki, which has a wiki for atheists, basically, which has an entire page on this problem. And it seems like a fairly straightforward problem, doesn't it? I mean, you can summarize it in 4 words. We see distant stars. How do you explain that in the context of a recent creation? And even some Christians struggle with this problem. Many don't know how to answer it. Dr. Norman Geisler, great defender of the Christian faith, great scholar, was not a young earth creationist though, did not agree with us on how Genesis should be interpreted. Why is that? Well, as he said, I think the speed of light is the crucial thing. If you could prove that the speed of light changes, you'd probably convert me to a young earth creationist. Dr. William Lane Craig, another brilliant scholar, another person who doesn't agree with us on what Genesis says. Why is that? He said the scientific evidence overwhelmingly supports the idea that the earth is very ancient. When you think that we can see the stars, that very simple fact That you can see these stars billions of light years away shows how ancient the universe is. So this isn't only a matter of answering skeptics. Even many Christians don't know how to answer this question. But it's actually even more complicated than what I've talked about so far. This isn't just a matter of things that are millions or billions of light years away. Even the things that are closer to us present certain questions. For example, when Adam woke up on day 6 and the sun went down and he looked up at night, was he able to see stars? Yes. I mean, it seems like he would, right? Why not? Well, what stars could he see? The nearest star system to Earth is the Alpha Centauri system. There's actually 2 bright stars here, as you see. To the unaided eye, they appear as one. This star system is over 4 light years away. So it would seem to take 4 years for the light to get here from there. So did Adam wake up to a completely dark sky, unless the moon happened to be up? And then 4 years later, him and Eve were looking up and boop, 1 star appeared? And then 2 years after that, another one? Did stars appear one by one? Or was he able to see all of them all at once? So you see there's other aspects to this question. I'm going to call this question the LTT problem, just as a convenient abbreviation tonight, for light travel time. So why does this matter? I'm sure this next section here will be review for most of us, but it needs to be said. The Bible doesn't give us specific dates for the creation of the universe, or stars, and so on. It does, however, give us genealogies that we can add up, and from that, ascertain when Adam was here. And it turns out Adam was roughly 6,000 years ago. There's a little bit of uncertainty precisely, but 6,000 is a pretty good value for that. So elsewhere in Scripture we see, Genesis 1 says, "In the beginning God created the heavens and the earth." And although this doesn't tell us specifically when that is referring to, we can, from other verses, get a good idea. Genesis 1:26 says, "So God created man in his own image. In the image of God created he him. Male and female created he them. And then God saw everything that he had made, and behold, it was very good. And the evening and the morning were the 6th day." Again, as I mentioned, Adam was created on the 6th day. Now, elsewhere in Scripture, in the book of Mark, we see where Jesus was having an argument with some of his detractors about divorce. They said, the detractors said, "Moses permitted a man to write a certificate of dismissal and to divorce her. But Jesus said to them, 'He wrote this commandment for you because of your hard hearts.'" Now here's the part that's relevant to our topic tonight. He said, "At the beginning of creation, God made them male and female." He's quoting that passage in Genesis that we just read, right? So Adam was created roughly 6,000 years ago, and Jesus confirms that that was at the beginning of basically everything. That everything was created at more or less the same time, give or take a few days. Now, some people have actually said maybe Jesus didn't know what he was talking about. Yeah, exactly. Not only is that heresy, it's contradicted by the Bible. John chapter 1, among other places, tells us that Jesus is the creator. All things are made by him, and without him was not anything made that was made. The creator would know when he did it, right? So that indicates that all of reality, everything we see, is about 6,000 years old, more or less. Why then do we see all these objects that are so far away? Does this disprove the Bible and confirm secular cosmology, of which the Big Bang is the consensus model today? Well, that's my topic tonight, the LTT problem. There's actually multiple approaches to solving this issue. So my time tonight is going to be broken up into 2 sections, inform and equip. In the inform section, we'll discuss theoretical ideas, if you will, different ways to approach this particular question. I'm not here tonight to present the solution, quote unquote, to the LTT problem. If you go to a talk on this issue, you will usually be listening to a particular person who has a particular favorite idea. I have my preferences and my personal opinion in this issue, as most of us do, who are involved in this, but there's multiple approaches being discussed in the creation movement right now. And so rather than try to persuade you of one solution, I'm here to provide an overview of the discussion. I think that's more useful. I'm going to be neutral in this as best I can and not reveal my own personal opinion. For each position I'm going to present has at least one credentialed scientist in the creation movement advocating for it. And by credentialed, I mean PhD in astronomy, physics, or astrophysics. So I'll go through multiple ideas being discussed right now. However, this issue is a little more challenging than some other issues within the creation movement. For example, the idea that a global flood happened on the earth. We can be confident that it did because the Bible says so. It says the flood happened. It talks about the stages of how it happened. The waters rose, they prevailed, and then they drained away. It tells us how long some of these stages were. So the Bible tells us what happened and how it happened. So we can be confident that we know what did happen. And moreover, we can actually go and gather evidence. We can go out and get rock samples. We can see if they were laid down by water, which sedimentary rocks show evidence of their deposition conditions. We can take slices and grind them up real thin and put them on slides and look under microscopes. We can send them off to dating labs and get information that way. There's all sorts of wonderful stuff we can do with evidence for the global flood. What can we do with biblical cosmology? How much does the Bible tell us about how the Lord created the universe? It tells us this. That's it. That's all we have to go on. Not much detail there. What about evidence? Well, we're looking at things from long distances. We're gathering light from objects that aren't here. We can't go take a star and bring it into the laboratory and play with it and see how it works. We can't go take samples from a supernova explosion, not that you'd want to be anywhere near such a thing anyway. So this discussion is more theoretical and more model dependent than some other issues with the history of the world. On the other hand, though, it does give us more freedom to bounce different ideas off of each other and to go in different directions. My overall point tonight is that we are not on the defensive here with this issue. The skeptics think they have us on the back foot if they haven't already knocked us out already, or so they think. But not at all. There's multiple approaches to this problem, as we will see. And as I said, I'll be discussing arguments for each position, and in some cases, counter-arguments as well. I'll tell you why somebody is advocating for each idea, and in some cases, I'll also say why other people are arguing against that idea. And other people in this context are other people in the creation movement, by the way. So, that's the informed section, the theoretical discussion of ideas. The equipped section is more practical. We're going to talk about things you can discuss with skeptics and actually, useful topics for that. I will talk specifically about how to discuss the LTT issue with the skeptic, and then I will finish the presentation tonight with a question for asking skeptics about cosmology in general and get people thinking. So, the LTT problem, what do we do with it? Well, it's all based on this formula, as we said, time equals distance over speed. And by challenging different parts of that formula, we can come up with different potential solutions to the problem. And let's talk about speed for a moment. The speed here in this formula is, of course, the speed of light. A while back, it was proposed perhaps the speed of light has decreased over time. Because if you look at past measurements of the speed of light, going back into the 1800s, the speed of light used to be measured at larger numbers than it is today. So if that indicates that the speed of light is decreasing over time, then that means light would have required a shorter time to go a distance than it would today. Does that make sense? A lot of people have heard of this idea. However, when this idea was discussed, a lot of people in the creation movement were interested in it, so it did receive a lot of discussion. There's some uncertainty about the proposal in the first place because, of course, decades ago, our technology was not as good as it is today, so the measurements back then were less precise, so the margins of error were larger. As we had good enough technology for a long enough period of time, we have been measuring the speed of light long enough that if it were decreasing, still it would have been measurable, and that has not been observed. Also, people have realized that if this idea were true, that would have certain implications. We would observe certain things in light from distant objects that we don't see. So this idea, as I said, received a lot of interest a while back, but has now largely been set aside and isn't really being discussed as a serious proposal anymore. So where does that leave us? This is the idea that most people have heard about, the only idea most people have heard about. So are we therefore on the defensive here? No, we are not. There's a number of current approaches to solving this problem. The first one's called mature creation, also known as light in transit. And going back to our formula, this time we're questioning the distance that the light traveled in order to get here, which of course would affect the time. This proposal is that the light beams were created in place by the Lord during the process of creation back in creation week. And the basic reasoning is this: if the heavens are to declare the glory of God, shouldn't they do so right away? Shouldn't Adam wake up to a night sky full of stars? So those who adhere to this prefer the term mature creation to describe it. Sometimes people call this the appearance of age model, but that's not really a good name. The claim is not that the things were created looking old, it's that they were created functional and mature. And we do indeed, it would seem, require mature creation to be true for at least part of creation initially. I mean, the earth had to be created mature. Did Adam wake up next to a pile of seeds and fruit pits that he had to plant in the ground and wait 4 or 5 years for fruit trees to produce fruit? No, of course not. He grew up next to mature fruit trees, right? Well, if the earth had to be created mature in order to be functional, then why not the cosmos too? So the proposal here is that we see distant stars because God created the light beams already in place between those stars and us, connecting us, if you will, right from the very beginning. Now, there are many people who don't like this idea, and the primary objection is that they feel it would make God deceptive. Why is that? Because it means we see things that have never actually existed. For example, in 1987, a supernova was observed, thus it's called supernova 1987A, and we saw a star explode. We saw the star there initially. We didn't know it was going to explode until it did, but observations had been made previously. And subsequently to this, we've observed the supernova remnant developing over time. So there's some good astrophysics going on here. But this object is 168,000 light years from us. Thus, the LTT problem, in a straightforward interpretation, would seem to indicate that it would take 168,000 years for light to travel here. Now, if the Lord had created a light beam in place from whatever's out there to here, then at creation, we would have this light beam already in place. And I'm showing you 6,000 years ago what it would look like. The red and yellow arrow represents the light beam from that object to us. So, for the first several thousand years of creation, we were, so to speak, consuming the light beam. As we received it, it's traveling toward us. And you like the Hollywood quality animations here, I'm sure, right? So, for the first several thousand years of creation, the first part of this beam had an image of the star before it exploded. Then, roughly 6,000 years after creation, the year 1987, we reached the end of the image of the star, and we saw an image of an explosion accompanied by some neutrinos. And subsequently to this, we're consuming more and more of this light beam. Now, if the Lord had created the light beam already in place, then, back up here, this star never actually existed, because its image was in the first 6,000 light years of the light beam, and then there was an image of an explosion, and now further back there's an image of an explosion a remnant rather, getting bigger and bigger. So you see the problem here. This objection to mature creation says God is basically showing us movies of stuff in the sky, and we have no way of knowing if any of it's real. In fact, we don't even know what's at the end of this light beam yet, because we haven't received light directly from it yet. If this light beam is 168,000 years long, we've consumed the first 6,000, there's still 162,000 years worth of it left before we're actually going to receive light that was actually emitted from whatever's at the other end of that beam. So everyone see the problem? Apparently you can't skip forward through these. Huh? Now, a counter objection, the answer to that objection, is that it wouldn't be deceptive if God told us what he did. When Adam woke up next to a mature fruit tree, was he deceived into thinking it had been there 4, 5, 6 years? Or was he not deceived because God said, I made that 3 days ago? If God tells us when he did things, and he does so clearly, then he's not deceiving us, right? And again, I'm not accepting either side of this question for my purposes tonight. I'm trying to present how the discussion is going. One more aspect to this that I haven't mentioned. We already saw mature creation has to apply to the earth at least. The idea that it can't apply to stars has a problem. There's at least one star that it should, in a sense, be applied to, and that's the sun. When Adam woke up on day 6, assuming it was daytime, could he see the sun? Could he see sunlight specifically? I think so. But the sunlight he saw was not produced by the sun. If our understanding of solar physics is that sunlight is produced by nuclear fusion deep inside of the sun, that creates photons, light. Those photons are immediately absorbed by other matter, then they're re-emitted, absorbed, re-emitted, absorbed. It takes thousands of years for sunlight to work its way out from inside the sun to the surface. Now, once it reaches the surface, it zips through space at the speed of light and reaches us in less than 8.5 minutes. But it takes thousands of years before it can do that. So if Adam could see sunlight, and for that matter, if people in the first few thousand years of history could see sunlight, which I believe they could, the Bible mentions the sun lots of places, then that sunlight was created, in a sense, mature en route to the earth. In a little bit different fashion than the supernova and such with these long light beams, but the same idea applies. So that's an interesting aspect of this to think about. So that's the first approach to this problem. Light beams being created in place, light in transit, or mature creation is another name for it. Second proposal is called Dasha cosmology. This comes from Dr. Danny Faulkner, who I noticed will be speaking here in November, and he'll probably give you more information about this idea then. But he was reading Genesis a while back, and where it says, God said, let the earth bring forth grass, the herb yielding seed and the fruit tree, and the earth brought forth grass, and herb yielding seed after its kind, and the tree. A lot of us tend to think of the creation process in Genesis as being a series of let there be's. Let there be light, zap, and there was light. Let the waters be separated, and they were. Let there be this, zap, and it was. Did the Lord create plants that way? Did he say, let there be plants, zap, and there was plants? It's not what it says, right? The Lord told the earth to bring forth plants, and it did so. So it seems that the earth brought forth plants in the normal way that it does, but it all happened on day 3, so it happened much more quickly than it normally would. But it's a normal, typical process just happening in a much shorter period of time. The Hebrew word here for brought forth is dasha. Thus, this idea is called the Dasha cosmology, because Dr. Faulkner started wondering if day 3, when the plants were created, was a normal process just greatly accelerated, maybe that happened on day 4, too, when the stars were created. What if the stars are emitting light, or I should say emitted light, as they normally would, and it reached Earth, as it normally would, just in a much shorter period of time through this supernatural acceleration? And this is openly an invoking of a supernatural process, by the way. This wouldn't obviously this wouldn't happen under normal circumstances. So this idea is basically that stars emit light as they normally do, and the reason we can see all these objects today is because the Lord accelerated everything within the time period of day 4. Now, many people don't like this idea because it's explicitly miraculous. It openly embraces a miraculous explanation. Right, exactly. What creationist doesn't? The answer to this is yes, it is miraculous, so is the universe. The universe shouldn't be here either if we're not going to accept miracles. Nevertheless, there's something, perhaps in most of us, perhaps even all of us, we would love to find an explanation for some of these issues that only uses today's physics, right? We'd love to be able to answer skeptics with an equation. See, here's how it all happened. It makes some people uncomfortable to say, yes, it was a miracle. I believe in miracles. But as we'll see later, the skeptic actually has the same problem, although his is actually worse in that sense, because ours makes sense. Miracles are consistent with our model because we know the miracle maker, whereas the skeptic does not. But getting back to this proposal, setting aside the issue of miracles, there's a more concrete objection to it. This idea doesn't make any predictions. A scientific model has to make specific predictions about what you observe or wouldn't observe. So if the model makes a prediction, then you can say, okay, I should go out and observe X, and I should not ever observe Y. And then you go and look. And if you see X and you don't see Y, that's supporting evidence for your idea. Maybe the idea is correct. If you don't find X and you do find Y, the thing you weren't supposed to find, then that's evidence against your model, and apparently it's not a good idea after all. Dasha cosmology doesn't make any predictions, though. There's no way to really test it, because whatever evidence we found, you could say that, well, that's just how the Lord did it. So some would object to this proposal on those grounds, that in order for it to be considered a good scientific model, we would need more detail about what we would expect. Now, this doesn't mean the model is not correct. It just means it's not testable, and it's difficult for us to really dig into it using normal scientific investigation. So that's the Dasha cosmology. And as I said, I'm sure Dr. Faulkner will talk about that in more depth in your November meeting. Now, to this point, I have discussed two proposals that, to various degrees, invoke miraculous processes. And a lot of people are hoping to have explanations for the LTT problem that are a little more concrete and a little more explicitly invoking of science and scientific principles. So that's what from here on, that's what we'll be doing. The third proposal is called the variable speed of light, VSOL. Back to our formula, now we're challenging the speed again. If the speed of light were variable and not absolute, then that would change the amount of time required for light to travel distances. Now, you may be scratching your head and saying, wait a minute, we already talked about speed of light decreasing over time, and you said it didn't do that. Correct. This is not a proposal that light has decreased its speed over time. This is a proposal that its speed varies by location. Specifically, how much gravity, the strength of the gravitational field in a particular location. After all, where have we ever measured the speed of light? All of our measurements have been done where? In the solar system. Mostly on Earth, a few farther out. We've never measured it outside of our solar system. Every measurement we've ever had, or ever made, has always been within the gravitational field of the sun. I mean, we only have a few spacecraft that even left the solar system. That happened very recently, and they're decades old and aren't set up to measure this. So if all of our measurements are done within the sun's gravitational field, what is the speed of light outside of a star's gravitational field? We don't know. Never measured it. We assume it's the same, but that is just an assumption. If gravity were to slow light down, number one, we wouldn't be able to notice it because we have only measured it here. Number two, that would change the time required for light to travel long distances, right? Because between stars, there's less gravity. And between galaxies, of course, you'd have vast distances with nothing producing a gravitational field. So conceivably, if this idea were true, light would be able to travel much farther distances over much shorter periods of time than is commonly thought. Many people have noticed that space-time behaves as a fabric. Mass distorts the fabric of space-time, and that's what we call gravity, and we can talk more about that in Q&A if this is a new concept to you. But many people have noticed that the equations describing this are very similar to the equations that mechanical engineers use to measure the deformation of a fabric under stress and strain and so on. And we know, incidentally, from this that mass and gravity will change the path of light through space-time. You know, light will bend around massive objects, even though it has no mass. So we know gravity already affects light in that sense. What if, in addition to changing light's path, it also changes light's speed? That being the case in deep space, as I said, potentially light could travel much more quickly, which would solve the LTT problem. I've had this idea in my creation talks for quite some time now. I was encouraged when the most recent ICC conference, there's actually a paper digging into this idea in more depth and actually making it more formal and mathematical proposals that can be investigated further. So I'm hoping that the creation movement overall will start paying more attention to this. I'll also note that we are not the first ones to do so. Secular cosmologists, at least some of them, are also investigating this idea. There are certain secular cosmologists who would love to have light speed be variable to solve certain problems that they have. My point is, this is not only a proposal that on our side of the thing, there's scientists across the spectrum that are looking into this as a viable possibility to explain certain things. So, variable speed of light is option 3. Option 4 is the anisotropic synchrony convention, known as ASC. That's quite a mouthful, isn't it? Who has heard of this proposal before? Very few people. Okay, that's good, because this one takes a while to explain, and I don't want to take the time to do so if everyone else's eyes are going to glaze over. This is an interesting idea. There's a lot of aspects to it, but as I just said, it would take a while to explain. So I'll limit myself to just the very first part of it, because it's useful. Getting back to our formula, we're going to talk about the speed again. What is the speed of light? We don't know. Well, C, okay, well, it's represented by C. That's correct. If you look up C, you'll be told 186,000 miles per second. That's not actually, well, it's not the one-way speed of light. That is only the two-way speed of light. When you measure the round trip of a beam of light, that's the number you'll get. What do I mean by that? Well, if you set up a mirror and fire a laser at it, bounce the laser off the mirror, and you have a clock, you can measure precisely how long the laser took to travel that distance. Then you can figure out the speed. What if, though, you wanted to measure the speed of light in only one direction, to go from here to there, but not back? The one-way speed of light. You actually can't do that. That's a measurement that's impossible to make. Not because we don't have good enough clocks or whatever, because it's physically impossible to do that. For various reasons, you would have to assume that you know the one-way speed of light before you can measure it, which is obviously impossible. And this is probably a strange concept to most people, but this is a well-known problem coming out of relativity. It's been discussed for decades. I mean, Einstein talked about it, and he lived 100 years ago. And there's a whole Wikipedia page on it. Over the years, there's been lots of proposals for potential ways that we could measure the speed of light going out one direction but not coming back. But ultimately, it's been realized, no, there's actually a subtle assumption in there, in that proposal, where you're assuming what it is before you can measure it. So in our daily lives, most of us don't grapple with the speed of light anyway. But talking about this issue, most people assume that the speed of light is the same in all directions. But that's just an assumption. You can also assume that it travels different speeds in different directions as long as the combined round trip value is 186,000 miles per second. So why is this a big deal? Because if you think about this formula, speed, does this represent a two-way round trip speed of light or a one-way speed of light? One-way, because it's calculating how long the light took to go from there to here. Turns out we can't know that number. You have to assume a number and then work with it in your equations. But you can make different assumptions, and you will always get the correct answer at the end, regardless of the assumption you chose, as long as you apply it consistently throughout all your calculations. My point is, the LTT challenge is based on a formula that is based on a number that is impossible to know. So ASC ultimately invalidates the LTT problem. This isn't a solution to the problem, it's an invalidation of it. The question itself doesn't make sense because it would require us to know something that is impossible to know. This idea as well is gaining more traction in the creation movement. The last ICC conference, there were several scientists who presented on it, and I know some of these people, they are continuing to work on it. So if you follow the creation movement closely, you will most likely be hearing more about this fairly soon. Option 5, time dilation. Going back to our formula, now we're not going to question distance like we did before. We're not going to question speed like we've done before. This time we're going to question time itself. What do I mean by that? Well, when we look out into the cosmos, almost everything we see is redshifted. There's a few things close by to us that are blue shifted, but everything else is redshifted. And once you look out far enough, everything is not only redshifted, but the redshift gets more and more pronounced the farther out we look. So what does redshift mean? Well, if a light source is emitting light towards you, but is moving away from you as it does that, the light beam gets, in a sense, stretched out. And the wavelengths get longer, it shifts toward the red end of the spectrum. The light gets redder. Conversely, if the light source is moving towards you, you can think of the light wave being bunched up, in a sense. That's a blue shift. So indeed, there are, as I said, a few things close by to us that are blue shifted. So those galaxies and such are moving toward us. But when you look out beyond our local neighborhood, everything is redshifted, and the farther out we look, the more redshifted it is. So everything is moving away from us, and the farther out we look, they're moving away from us faster and faster. So what does this mean? Well, imagine that each slice here represents a particular stage in the universe, and we are in this slice right here. So you see the galaxies there. If all the galaxies are moving away from us, then in the future, they're going to be farther apart than they are now. So this is the idea that the universe is expanding. You've probably heard that if you look into cosmology. This is where that comes from. The fact that all these distant galaxies are moving away from us. And we see that in all directions that we look. And that's important. We'll come back to that in a moment. But this isn't so much a question of the future. Now run the mental movie backwards and think backwards in time. If everything is moving farther away from us now, that means it used to be closer to us in the past, right? Run the movie all the way backwards and you reach a point where everything, used to be in the same place. This is the basic idea behind the Big Bang model. Now, again, I don't accept the Big Bang, but this is where they get that idea from. As I said, we see this in all directions. So think about that. This means the universe is expanding, or that it was expanding at the time the light was emitted, and we see that in all directions, which makes it appear that we're at the center of the expansion. So there's two possible ways to interpret that. Well, the straightforward way is to say that we're at the center of an expanding universe, right? But if there were a center of the universe, that would be a special place. If we were at that place, what would that make us? Special. And that would have implications, right? So skeptics don't like that interpretation. So of the two possible ways to interpret it, they like the first one, which is that we appear to be at the center of an expanding universe because it would look that way no matter where you were. It would look that way from everywhere. So they modeled the universe without a center to do away with the implication of what we just mentioned. And so in their model, you would see these redshifts in this pattern anywhere you were in the cosmos. Of course, the more straightforward interpretation is that we appear to be at the center of an expanding universe because we are. Now, don't misunderstand me. I'm not saying the Earth is stationless and the sun is revolving around us and all the rest of it. This is not geocentrism. This is saying that our galaxy is somewhere close to the center of an expanding universe. The Earth is still going around the sun is going around inside the Milky Way, and so on. The skeptical interpretation, though, that there is no center, and therefore we can't be at one, is called the cosmological or Copernican principle, that the universe can have no center. And this is a foundational assumption of the Big Bang model. In fact, you have to decide if there can be a center before you can even do any math if you're going to make a cosmological model, because that changes how relativity gets applied. So first they assume the universe has no center, then they apply general relativity and do some other things, and that's where the Big Bang model comes from. So I mention this now to make a point. There are a lot of Christians out there teaching that we need to embrace the Big Bang model because it says the universe had a beginning and that's consistent with Genesis. Well, first of all, the Big Bang isn't consistent with Genesis, but without digging into those details, my point right now is that there's basically an anti-God hypothesis built into the foundation of the Big Bang model. And people should be aware of this, I think. But it is just an assumption. It's not an observation. And if it's only an assumption, then we're free to choose a different assumption, right? We're free to assume that maybe we appear to be at the center of an expanding universe because we are. So this is how it applies to LTT. If there's a center to the universe, then there can be a center of mass. And if there's a center of mass, you can have something called time dilation, where time changes. What do I mean by this? Well, we know from general relativity that gravity affects time. If you're in a gravitational field, the stronger the gravity is, the slower time flows for you. And if that sounds weird, another way to put it is any possible clock you could construct would measure time more slowly, regardless if it was a mechanical clock or a chemical process or whatever. Any physical process will occur more slowly in stronger gravity. Relativity predicted this, then it was confirmed in experiments, and today it's actually so commonplace that some of our technology has to compensate for it. I'm showing you a GPS satellite here. I got to work on this program for a while. GPS operates according to very precise measurements of time. Your device has to communicate with several satellites, and the difference in time between you communicating with this one versus these others helps to figure out where on the Earth's surface you are. Turns out GPS experiences time slightly differently than we do. Why? Because they're out in space above the atmosphere. They're farther out of Earth's gravitational well. They're still influenced by Earth's gravity, of course. I mean, they're in orbit. But we have a little more gravity down here, or I should say the field is stronger down here on the surface than it is up there. And this produces a difference in how time flows. It's not much, but it's measurable, and GPS has to compensate for it, otherwise it wouldn't work. So why is this relevant to our topic? Because a few years ago, a Bible-believing physicist named Dr. Russell Humphreys was reading Scripture and noticed that in multiple places, the Bible says that not only did the Lord create the heavens, He stretched them out. Now, is this poetry, or does it describe something that the Lord actually did physically? Well, Dr. Humphreys started wondering, what would that look like? If the Lord stretched out the heavens early during the creation process, that means the heavens started out in a smaller volume before the stretching, right? Well, if you took the amount of matter in the universe and packed it into a tightly compressed enough volume, you would have a black hole. So in this Hollywood quality graphic that I'm showing you here, the black ball represents the matter of the universe. The dotted line represents the event horizon. An event horizon is the distance within which a black hole does all sorts of weird things and is a black hole. So the event horizon is it's not like a shell, a physical thing. It's just a distance from the center. So outside of the event horizon, things are normal. Inside of the event horizon, you're in the black hole and weird stuff happens. So let's say that in the very beginning, the universe was inside of a black hole. And now the Lord starts stretching. As the universe gets bigger, the black hole gets smaller. So you see the event horizon shrinking as the universe gets larger. And now the Lord starts to create things from this matter. He continues stretching. Eventually, the universe gets big enough that the black hole gets small enough that the entire universe is no longer within it. And this is where it gets interesting. Now, some of the universe is outside the black hole while the rest of it is still in. And in this scenario, the Earth would still be inside because we're more or less at the center of the universe, right? So this means time is now flowing outside the black hole, whereas inside a black hole, time does not flow. Time essentially stops. So this is, of course, outside of our everyday experience, but we already talked about gravity affecting time. Lord keeps stretching, universe gets bigger, time keeps flowing out there, whereas it's essentially stopped here. Eventually, the universe gets large enough that the black hole collapses and goes away. From this point onwards, time flows consistently throughout the universe, uniformly, other than local variations due to being next to a massive object or something. But what happened before this point? Lots of time passed out here, millions or even billions of years perhaps, while what happened here? 24 hours? If you ask Dr. Humphreys, how old is the universe? He'll ask you, according to which clock? Because this one measured millions and billions of years out here. This one measured hours or a few days. Which one's correct? Yes. They're all correct. Each clock correctly measured time according to where it was. What perspective is Genesis written around? Where is the book of Genesis? Where is it in the creation part? It's focused on the earth, right? So the earth would experience very little time during this scenario, whereas lots of time would pass out here, which would give time for light to be produced and light to come to us. So this is called gravitational time dilation. Now the idea I just shared with you was Dr. Humphrey's first version of this model. He has subsequently developed it further. He wants to account for things like the waters above and some other issues. But his later ideas are more complicated, and I like talking about the first one because I think it communicates the idea more clearly. But you get the idea here, right? Depending on how you arrange matter in the early universe, time will flow differently in different places. So you can have one day pass here while millions and billions of years are passing out there. So that's time dilation. I should say gravitational time dilation. Because it turns out there's more than one time dilation available too. These 5 proposals are the main ideas being discussed in the creation movement right now. But this is not an exhaustive list of possibilities. There's other things we can look into. For example, I told you that GPS has time dilation going on with it, which is about 38 microseconds per day. I implied that all that is due to gravitational time dilation, but it's not. Gravitational time dilation actually produces about 45 microseconds per day of time dilation, and then kinetic time dilation by the motion of the satellite, actually cancels out about 7 of that. So kinetic time dilation is another way that you can have time flowing differently for different objects at different locations, depending on how they're moving. So now, currently, there's no creation cosmology based on, or that includes even, kinetic time dilation. My point is that this is another tool in the toolbox, so to speak, another way to account for time flowing differently across a universe as it's being created. There's other ideas too beyond this, but hopefully you get the idea. So this is not a showstopper issue for us, is it? There's lots of potential ways to attack this problem, and possibly, well, first of all, there may be more answers, there may be more proposals coming that we're not aware of yet, of course, or another possibility, I presented these as if they're mutually exclusive, but they're not. Perhaps a model will come along that has different aspects of this, of each one, or at least some of them, combined. Now, by this point, you may be thinking, this is too much. Why are we being bombarded with all this? Why didn't you just give us the answer to the problem? Well, this is not a bad thing that there's multiple proposals on the table here. This is a good thing. This is healthy. There's multiple ideas from multiple scientists who are all credentialed and who are all passionate about their ideas and are discussing them with each other. This is how good science is done. It wasn't that long ago where nobody was talking about this issue, really. And if you ask someone about it, they'd say, I don't know, God must have created the light somehow. And that was about the answer you'd get. Only in the last few years are we getting all of these good ideas being bounced off of each other. And iron sharpens iron, right? I mean, this is how we get really good models as a result of it. As one of the speakers at the conference I was at last week said, this is a great time to be a biblical creationist. There's more scientists talking about more ideas, more evidence than there ever has been before. So this is not a bad thing, this is a good thing. So I said I would inform and equip. That brings us to the end of the inform section, talking about theoretical ideas. We see there's multiple ideas being discussed within creation science on this issue. Now we'll talk about the more practical session, equipping. How can we use these ideas and even broader cosmological ideas to discuss with skeptics? Well, if a skeptic challenges you on the LTT question, number one, you could answer with some of the solutions I just presented and discuss some of the ideas. Did you know mass affects gravity? Do you know mass produces gravity and affects time? Most people haven't heard that. But you could also be a little more direct and point out that the skeptic, assuming he believes in the Big Bang model, has no right to question you on it because the Big Bang has an LTT problem of its own. So let's talk about that for a moment. We look in all directions and we see all these distant objects, right? Let's say we look in one direction and we see a galaxy that's 10 billion light years away. So the skeptic is still thinking in LTT terms. He thinks that light would take how long to get here? 10 billion years. We look in the opposite direction, and to keep the math easy, we'll use the same number. How long did light take to get from there to here? 10 billion. Thank you for not asking me to complete that sentence. So, that being the case, how long would it take for light to get from that edge of the universe all the way to that edge? 20 billion. Simple math, right? Now, even in a Big Bang context, the universe is less than 14 billion years old. Has there been enough time for light to travel from one edge of the universe to the other, even in the Big Bang model? No. So, in a Big Bang interpretation of cosmology, then, light has not traveled across the entire universe yet. Now, your first reaction might be, but wait a minute, if the Big Bang says the universe is expanding, yes, it's 20 billion light years across now, but in the past it was smaller. So that would mean light could travel across then because it was smaller, right? Actually, no. Because of today, and I'm using round numbers here, if it's 20 billion light years wide but less than 14 billion years for light to travel, let's look into the past and say the universe is half of its current age. Then the universe would only be 10 billion light years across, but the universe would be less than 7 billion years old. 1/4 of the current age, only 5 billion light years across, but there's less than 4 billion years of time. So you see that inequality remains regardless of what stage in the universe you're talking about. Now this assumes that the universe has been expanding at a linear rate, which isn't quite true, but the principle still holds. So do you see the problem? In the Big Bang, there's never been enough time for light to travel across the whole universe. Okay, so who cares? Well, here's why we should care. The Big Bang model says different regions in the universe, since light could never travel across, they have never been in causal contact or thermal contact. One region has never been able to influence another region. And if light can't travel across, then nothing else has either, because light is the fastest thing, including heat, because heat travels as radiation, right? So if heat has never traveled across the universe, and if different regions of the universe started out at different temperatures, they should still be at different temperatures, because there hasn't been enough time for them to exchange heat and for heat to go from the hot sections to the cool sections so that they would even off. If I have a hot cup of coffee and I put it here right now, there hasn't been enough time for the heat to travel from inside the cup to the room. Thus, it's hotter. If I wait long enough, though, it will do that, right? The heat will come out, the room gets a little bit hotter because it gets spread out throughout, and the coffee gets colder until it's all the same temperature. So if there's enough time, things at different temperatures will arrive at the same temperature. But applying this to the Big Bang then, if the Big Bang says different regions started out at different temperatures and there hasn't been enough time for heat to be exchanged, they should still be at different temperatures, right? But they're not. The entire universe is the same temperature, down to 1,000th of a degree. This is called the horizon problem. We see the universe at the same temperature. So apparently light, in the form of heat, has traveled across the whole universe and everything has equalized itself out. But the Big Bang says there's never been enough time to do that. And there never will be, exactly. Secular cosmologists are aware of this problem. They try to solve it with something called inflation. The proposal that right after the Big Bang happened, it blew up at multiple times the speed of light and then stopped and produced a normal expansion after that. Ask why that would happen, you'll be told, well, there's an inflaton field, a new particle called the inflaton. Has anyone ever seen an inflaton? No. Is there any room for an inflaton within particle physics? No. Why do we believe in this then? Because if this is not true, then the Big Bang model would be proven false. Hello. Yeah. Hello. So you see the cart's, getting before the horse here. Other problems with inflation that we won't take time to discuss. I will note, however, that even some of the architects of inflationary theory don't accept it anymore. But without inflation, the horizon problem is an insoluble problem for the Big Bang, and all by itself is enough to discredit the Big Bang model. So my point is, the Big Bang model has an LTT problem of its own, doesn't it? The universe has apparently equalized itself in temperature, but the Big Bang model says there's never been enough time to do that for light to go all the way across and for that to happen. So those who live in glass houses should not throw LTT problems at each other. Last thing I'll talk about is something I call the secular dilemma. And this is again, a practical thing that you can use when discussing with skeptics, not just about LTT, but about cosmology in general. And it's based on a 6-word question, a simple question. Did the universe have a beginning? And if you take anything out of the talk tonight, I'd like it to be this. This is the most practical and useful thing. I mean, it's all well and good to talk about maybe light travels faster between galaxies. That's not going to affect your daily life at all, right? But this you might find useful in a variety of situations. Okay, so the question, did the universe have a beginning? How many possible answers are there to this question? 2. Either yes or no, right? So yes means the universe had a beginning. No means it didn't have a beginning, which means it would be therefore eternal. Why do I call this the secular dilemma? Well, a dilemma is when you have a choice between equally unfavorable or equally bad alternatives. And for a secular cosmologist, this question is a dilemma, because when building any cosmology, you have to decide if you're going to have a beginning of a universe or an eternal universe. For a secular cosmologist, both of these answers are bad. Let's talk about why. If the answer is yes, there was a beginning, well, if the universe had a beginning and the universe is everything, then everything had a beginning. If everything had a beginning, what existed before the beginning? Nothing, right? Because if there was something before the beginning, then whatever began wouldn't be everything anymore, right? So it wouldn't be the universe. So if everything had a beginning, then before the beginning there could have been nothing. Anyone see that? Now the Big Bang is, at least formally, an idea that indeed there was nothing and then there was everything. So I actually have a graphic of what the universe looked like before the Big Bang. No, it's just... Sorry, it's just artist conception. But here's a question. Can nothing make everything? Can you go from nothing to everything? Can you go from nothing to anything? No. Because nothing can create nothing. Nothing can do nothing. From nothing comes nothing. As Dr. Phil Fernandez once said, you can't tell me nothing made everything. I know too much about nothing. Setting that aside, so far this seems like common sense, right? But it's actually captured in a principle in physics, sometimes called the first law of thermodynamics, but has since been broadened to an idea called the conservation of mass energy. So the conservation of matter and energy means that the total combined amount of matter and energy in the universe never changes. That means you can't get them from nothing. You can convert one to the other. When one goes down, the other goes up, but the total amount of both together is constant. And what do I mean by convert them back and forth? Well, you may have heard E equals mc squared, famous equation. That tells us about the relationship between matter and energy, that a little bit of matter contains a lot of energy. So we can convert one to the other, but we can never create either one from nothing. So, for example, the most efficient way we know how to create matter to energy is in a nuclear explosion. A little bit of stuff converts into a lot of energy. But you need the stuff, right? You don't get the energy from nothing, because that violates physics. We can go the other direction and convert a lot of energy into a little bit of stuff. We do that in particle accelerators. You get little chunks of matter zipping around at close to the speed of light, smash them together. More matter comes out of the collision than went in. Not just number of particles, the amount of physical stuff. But are we creating the stuff from nothing? No. We're converting the kinetic energy, the energy of motion, into matter. So we can convert energy to matter and matter to energy, but we can never create either one from nothing, because that violates physics. And we see this principle in our lives every day. I mean, think about this. Why do you need to eat food every day? Regardless of how difficult the process might be sometimes. Because your body needs energy. Can't make it from nothing, that violates physics, so you have to get it from the chemical energy in the food after you actually get it in your mouth. Why do you get a bill from the power company every month? Because you need energy for your appliances, can't make it from nothing, that violates physics. Have to get it from some other source, like the chemical energy stored in coal, or the gravitational potential energy in flowing water, or solar energy. And the sun can't make it from nothing either, because that violates physics. It has to do it by burning hydrogen or whatever. In fact, this principle, if this principle weren't true, you couldn't even be seeing this presentation tonight, because some of the principles of circuit design are based on this idea. So very, very fundamental idea in physics. Conservation of mass and energy. You can't make either one from nothing. As one of my textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed, except in the Big Bang model, which says that everything came from nothing.
One exception.
And therefore, one exception, and therefore violates physics. Now, there are people claiming that it doesn't violate physics. I'm not going to take the time to wade through this. You can ask in Q&A if you want specific information about that. My point for now is, if you want to answer yes to the secular dilemma, you're violating physics. So that option is off the table. What about the second option? What about the answer no? Well, if the universe didn't have a beginning, then it must be eternal. Does physics allow the universe to be eternal, though? Earlier I mentioned coffee. If you walk into the room and there's a hot cup of coffee sitting there, has it been there for a long time or a short time? Short time. Why? Because it's still hot. It hasn't cooled off yet. Can it have been there forever? No. Had it been there forever, it would have cooled off forever ago. We can apply the same reasoning to the universe. Is there anything in the universe that hasn't cooled off yet? Our sun, stars in general. If the universe were eternally old, if it had been there forever, stars would have burned out forever ago. But they're still there. Indicates the universe is not eternal and not eternally old. Now, some people say new stars can form. There's actually problems with that. But even if that were possible without a creator, that still requires energy, of which there's a finite amount. It too would have been gone forever ago if the universe had been here forever. So heat energy is still very unequally distributed across the universe. This tells us the universe had a beginning, right? It can't have been there forever. And another note to people, to Christians who want to believe the Big Bang model, a lot of people say we need the Big Bang model to prove the universe had a beginning. We don't need the Big Bang model to prove that. If you want to prove the universe had a beginning, go outside and look up. Do you see the sun? Do you see stars at night? If yes, if so, then the universe had a beginning. Everyone see that? Skip forward a little bit. So, back to our dilemma. We saw that the answer yes violates one law of physics, and now we see that the answer no violates a different law of physics. And if you're a secular cosmologist, those are your only two choices. Regardless of which one you pick, your model is going to violate physics one way or the other. As Christians, we have a third option. Yes, the universe is not eternal, because we see stars. Therefore, it had a beginning, but there's a supernatural creator outside of the laws of physics who's responsible for the universe existing. Because to explain the universe, there's just three possibilities, really. Either it was formed by a creator, or it formed without a creator, or it didn't form at all because it's always been there. We saw option 2 doesn't work because it requires something to come from nothing. We saw option 3 doesn't work because we still see stars. The only one left is that it was formed by a creator. So that's the secular dilemma. Since the secular cosmologist denies a creator, he is left with only two options, and they're both bad. They both violate physics. And this is a great conversation starter, by the way. Gentle question, right? Did the universe have a beginning? What do you think? Let people work through the implications and point out the implications of all that. I also think, and this is just my personal opinion, I think this is evidence of God's grace. I mean, God's grace is beyond our comprehension in so many different ways. But the Lord could have created the universe any way he wanted to, right? He could have made a universe that looked like it formed by natural processes, but many of us would struggle with that, right? I mean, he would have the right to make the universe look however he wanted and then say, don't worry about how it looks, I made it, trust me. But many of us would struggle with that, right? Because we're weak. He didn't make the universe like that, though. He made the universe to operate according to laws of physics that show he's responsible for it. In his grace, he placed us in a universe that looks created. And I think that's wonderful. So, tonight we talked about distant starlight. We talked about theoretical ideas in the informed section. There's multiple approaches to solving this problem. Then we talked about practical ideas, the fact that the Big Bang has an LTT problem of its own, and then a broader cosmological issue that the secular cosmologist has to grapple with this dilemma, where any model he can come up with has to pick one of those two choices, and each one violates physics in a different way. So, resources for more equipping. This is my website, creationastronomy.com. As you might guess, you've gotten a rather unusual perspective on astronomy tonight that you're not going to find in a whole lot of places. There's an email newsletter there for you can get. It's free. The sign-up form is at the bottom of every page on the site. It only comes out a few times a year at this point, so you won't be spammed too much. Also on the back table, I have a set of 3 DVDs. Let me ask a quick question. Who has the first DVD in this series already? A few people. You may or may not know, number 1 in this series was updated last month. So let me first describe what it is. Volume 1 in this 3-part series discusses planets and moons of our solar system. Each planet, it turns out, discredits secular origins models in a different way. And as you might have gathered from my presentation, I love beautiful visuals and nice pictures and all the rest of it. So this is a full presentation of all these beautiful objects, some of the most beautiful things God has created, discussing how all the planets and some of their moons disprove secular origin models. And for those of you who bought it before, as I said, this has been updated recently. It's now actually a 2-disc set because it doesn't fit in 1 disc anymore. So very in-depth on this subject. Volume 2 is on stars and galaxies. Where do stars and galaxies come from? Can secular origins models explain them? The answer is no. Volume 3 is on the Big Bang model itself and the origin of the whole universe. Where did the universe come from? Is the Big Bang model good science? I think we just saw the answer to that. The secular dilemma material was actually taken from this DVD, and there's a lot more information about cosmology in it as well. And they're all designed to answer the question, what do the heavens declare anyway? Not the Big Bang model. The heavens declare the glory of God. So thank you very much for your attention. That's the end of my presentation.